Welcome students, and we're getting into how to find area underneath a curve, but the regions are going to switch back and forth. So you have to kind of be careful with this. Actually, I'm sorry, I want to go back to question one here and let's start with this one. But let's look at the notes here. I want to kind of verify something. Notice that the red line is the f function, the blue line is the g function. And let's just say I wanted to find this region here. And then I wanted to find this region here. And I did put some cutoff points at A and B, and it starts off at 0. I always like to kind of rephrase this or phrase this as top minus bottom. So in this case, it's red minus blue, but once you get to this region, it's blue minus red. So as an example, in the first one, it would be F minus G, and it would actually be from 0 to A. This one would be from A to B, but then it's going to be G minus F. So a lot of details that you have to kind of pay attention to. Just be careful because the regions switch, and that's really the main focus on this. There are 4 problems. I kind of recommend the trig problems do them by hand because they want the exact answer. But the last couple problems, there's no trig. You don't have to worry about that. All right, let's go ahead and scoot this up so I can kind of take a look at this. First of all, if you notice this region here, it basically is the black line, that's the top. And then on the other half, it's the red line, that's the top. So it's kind of split in half here. Now, I went ahead and made a Desmos graph with this. Let me kind of highlight this. And this is the region that they're trying to find, is this region right here. So I wish I knew what this intersection point was. So if I actually highlight that, let me highlight that point again. Just remember that, pi over 4. That's actually going to be a helpful tool for us there. Let me get back to this. So now I can actually set up the equation. So if I look at the left side of this, the black line, and real quick, the key difference about graphing sine and cosine, sine starts at the origin, cosine starts at the amplitude. So I'm going to do the left side first, this region. Let me get my pen ready here. So it's going to be integral 0 pi over 4, wow, that's a 4, 4 sine of x dx. That's just the left-hand side, plus, and then I got to add the other region, pi over 4 to pi over 2, and it does stop at pi over 2, as you can see here, it does stop there, and they even give you the constraint all the way up to pi over 2, so definitely pay attention to that, watch out for that. Pi over 2, as you can see, the constraint is cut off there. And the other half of the graph, since it's on the top there, it is cosine, so 4 cosine of x dx. Running out of space there. Hopefully you can read that. Oh, dang it. I'll get rid of that. Dx. All right, so looking at my picture here, I have to take the antiderivative. I'm going to go ahead and do the first half in red here. And what this is going to be, the antiderivative of sine is negative cosine. So it's going to be negative 4 cosine from pi over 4 to 0. I'll solve that here in a sec. Take the antiderivative of this region, and the antiderivative of cosine is actually sine. And I just got to plug in pi over 2 to pi over 4. And you guys should know the rest here. I just got to take the top, plug it in, take the bottom, plug it in. Let me go ahead and rewrite this. Negative 4 cosine of pi over 4 minus, and now I have to put the other part, negative 4 cosine of 0. That's just the first half of this part, the left side of the graph. So let me kind of squeeze in the other part here. Plus 4 sine pi over 2 minus 4 sine pi over 4. Because it's top minus bottom, just remember, I'm sorry, not this isn't the top minus bottom, but you take the top, the left side minus from the right side there. And actually, if you just use your unit circle, go through the whole steps of this. Again, I'm just going to go through and convert this. This will be square root of 2 over 2. This will actually turn into a plus. Cosine of 0 is actually 1, so it's 4 times 1. The other half here, sine of pi over 2 is that's at the top. So sine at pi over 2 at the top is 1, so that becomes 4. And then sine at that location becomes negative 4 square root of 2 over 2. Well, if you notice here with the fractions, what we have, we can actually just take the fraction and take 4 divided by 2, in this case negative 2 square root of 2 plus 4, and then the other half is 4 minus square root of 2 over 2. And combine my like terms, combine everything together, I get 8 minus 4 square root of 2. And it is the correct answer. I have gone through and verified everything, make sure it's correctly. All right. Oh, let me go back and actually state one more thing. If you do the question help, they have you find the whole region of this red part underneath the graph and then just subtract this region off of it. You could do it that way. Not fun, but that's your choice there. All right, I'm not going to go through all of this problem here, but again, if you notice, I went to my Desmos graph. There's the two graphs. They have this region shaded all the way up to pi, and you should know that pi is 3.14. So I got to know where does it change at this location. So again, if I just click on it, I can find the intersection point there. Let me go back to my graph. And so on this one, you just got to set up, again, top minus bottom. Let me go ahead and set up the equation here. So on the left-hand side is going to be integral 0 to 2 pi over 3. The top is cosine. The bottom is, top minus bottom, so I got to subtract that. Minus bottom is going to be cosine 2x. That is just the left side. So it's just this region that will find the area of. Now I still got to find this region. And it's going to be plus integral 2 pi over 3. How far does it go over here? What's the constraint? And it does give it to you in the question there. It does say it stops at pi. Top minus bottom, it's the red line on top of the blue line. So top minus bottom here, cosine x dx. Now, in our notes, back whenever I gave you that one paper, if you just take notes of this, I do have something that says cosine of ax dx. If you take the antiderivative, it does turn into 1 over x sine ax, and then obviously plus c, but I don't need the plus c in there. So when you take the derivative of this expression, since that a value is 2, it's just going to be 1 over 2, or 1/2 sine 2x. I'm not going to finish this problem up. I'm going to go ahead and let you guys finish it. It is a lot of unit circle work, so definitely have your unit circle available. The remaining problems, you're able to just type them into the calculator. And again, I would just type in a calculator. Just be very careful how you type in your solution. If you have any other questions or concerns, definitely meet me online. We can Zoom and actually go through over some of the instruction. Thank you and have a good day.